Okay, the combined gas law. We can take Charles' law and Boyle's law, which we talked about on Tuesday, and combine them into one relationship. Because sometimes we have more than two things changing. We might have all three things changing. So the combined gas law looks like this. P1 V1 over T1 equals P2 V2 over T2. And if you look at that, you can recognize that if you just look at the numerator, there's Boyle's law. And if you leave the p's out because they're not changing, then you've got Charles' law. Excuse me, so they're both kind of hidden in there. The amount of gas has to be constant when these changes occur. And again, the temperature is in kelvins. It only works with the temperature in kelvins. Let's do an example. A sample of gas has an initial volume of 158 milliliters at a pressure of 735 millimeters of mercury and a temperature of 34 degrees Celsius. If the gas is compressed to a volume of 108 milliliters and heated to a temperature of 85 degrees Celsius, what is its final pressure in millimeters of mercury? And the answer is purple because aliens don't wear hats, right? Yeah, it's like, what on earth? Just all these words and numbers and blah, right? Anybody feel like that? Yeah, okay. That's a very normal reaction. We can figure this out. We read through it. It sounds all crazy like that. We say, okay, Mrs. K said we need to make a table and write down the numbers. So let's do that. Let's make a table and write down all these crazy numbers. So we're going to have two conditions. So we'll make two rows here. 1 and 2, and then we'll just start with the first number, 158 milliliters. We write that down. That is the volume, right? It says volume of, so that's a big clue. The other thing is milliliter is a unit of volume. So we're going to call that column. Yeah. We're going to call it V for volume. The next number, write that down. 735 millimeters of mercury. What is that? It's the pressure, right? Pressure of, and then we've learned that millimeters of mercury is a strange sounding unit, but it's a pressure unit. So this is the pressure column. And then we go along and we go along and we come to 34 degrees Celsius. Okay, we need to write that one down too. 34 degrees Celsius. And what do we do to degrees Celsius? We convert to Kelvin right away, because otherwise we forget. So 34 plus 273, 307. So I'm just going to write what it equals, 307 Kelvin. And I'm going to extend my table because I didn't make it long enough, or I'm writing too big, one or the other. And that is the temperature. So I'm writing the numbers down just in the order I come across them, and then I'm identifying what variable they are. We've got pressure, volume, and temperature so far. If the problem doesn't tell you, then you look at the unit, and that will give you a hint. So now we're going to continue on. If the gas is compressed, so this is our change. There, in the words, there's going to be something that indicates that it was heated or cooled or put into a different container or something happened to it. Here's our change, so then everything after this is going to be number 2, row 2. The gas is compressed to a volume of 108. So this is a volume. I want to write it in the volume column, 108 milliliters. The next number is 85 degrees Celsius. Which column should I put that in? The temperature column. So 85 degrees Celsius, and what do I have to do to it? Convert to Kelvin. 85 plus 273, 358. 358 Kelvin. and there's no more numbers. So there's my table, and there's a blank square, isn't there? An empty one. Now let's, oops. What did I do? What are they asking us to find? What is the final pressure, and they're specifying units, in millimeters of mercury. So this blank here is going to be our final pressure. It's in column P, row 2, so let's call it P2. Then we've got everything labeled in the same way that those numbers show up in the equation. Now my table ended up being really big, so I'm going to get a little creative here and create some space, just because I can. We don't really need to see that stuff up there. I just need a little space to rearrange the equation in. We have volume, pressure, and temperature changing. So I'm going to let you have a 3x5 card, and you will probably want to write these these gas laws on there. And one of the things sometimes is hard is to know which one to use. Well, look at your variables. You've got 3 variables, and they're changing. We've got volume, pressure, and temperature. We want to use the equation that has all of those in it. If we use Boyle's law or Charles' law, we're left with a missing variable. So we're going to use the combined gas law, which is P1 V1 over T1 equal to P2 V2 over T2. What are we solving for? We're solving for P2, so I'm going to make that yellow just to kind of highlight it. The equation has fractions. What should we do before we rearrange? Get rid of the fractions. How do we do that? Cross multiply. So we're going to cross multiply and get rid of the fractions. So we take the numerator on one side, P1 V1, multiplied by the denominator on the other side of the equal sign. Then we take the denominator on the left, T1, and multiply by the numerator on the right, P2 V2. If you have trouble with this, please ask me about it in lab. Okay? Now we can rearrange this. We want P2 by itself, so we're going to divide by T1 because we want to get rid of it, and we're going to divide by V2 because then they cancel out, and we've got P2 all by itself. But if we do something to one side of an equality, we have to do the same thing to the other so it's still equal. So we divided that side by T1 V1, we're going to divide the other side by T1 V1. Thank you. Yes. It's so easy to do that. Over here is V2, and I had a brain fart and wrote the wrong subscript. Okay. Now we can put numbers in and calculate the pressure. So I think I have enough room down here. So I'm going to rewrite that. The P2, it's just more convenient to put it on the left, is equal to the rest of that. Copying carefully, P1 V1 T2 over T1 V2 TV2. So now I'm going to plug numbers in. Pressure 1, and include the units. I know it's annoying sometimes, takes up more space. Do it anyway. 735 millimeters of mercury. Volume 1, 158 milliliters. Temperature 2, 358 Kelvin. All of that divided by T1, 307, times V2, which is 108 milliliters. Let's look at our units. We've got milliliters divided by milliliters. We have Kelvin divided by Kelvin. We're left with millimeters of mercury. That's a good sign. If you get things in the wrong places, you could end up with the units not canceling out. This part down here, the rearranged equation, and the rearranged equation with all the numbers plugged in and their units, this is what I consider the minimum that you should write down and show your work. Okay, that's the minimum. If you need the table and writing out how to rearrange the equation, that's great. If you can do that in your head, that's great too. But this part down here, right here, this part is the minimum. You should always write that out. Now, do this on your calculator, because there's a common mistake people make, and it has to do with that 108. We are dividing by 307. We are also dividing by 108. And yes, it looks like they're multiplied. And if that is really how you see it and you really want to do it that way, that's fine. But then you need to, on your calculator, let's do this a different color. Then you need to put parentheses around that if you're going to multiply there. Personally, I don't do it that way. But you can do it that way and get the right answer. You have to use parentheses though. Okay, so when I do it, I do 735 times 158 times 358 divided by 307, and then I divide by 108. Oops. Okay. My calculator is showing me 1253.9 blah blah blah. How many significant figures should I report in that answer? 3. All these other numbers had 3. So I want to keep this digit right here. That's in the tens place. I need to be careful when I round. I can't round this to 125. I should put it in scientific notation to round it. And so scientific notation tells me it's 1, 2, 3, it's times 10 to the third. 1.25 times 10 to the third, and the units are millimeters of mercury. And there's my answer, hiding down in the corner. And that is the final pressure as asked for in the question. Any questions? Did you get the number on your calculator? Okay, you just have to watch out. Anytime you have 2 numbers in the denominator, you have to be careful. It's a shame to do all of that work, set it up correctly, and make that one little button mistake on your calculator.